Hello everyone, September 20th. Alright, get right into it. Sum of even numbers after queries. Given an integer array nums and an array queries where queries I is value I, index I. For each query I, first apply nums index equals nums index plus value. Then print the sum of the even values of nums. Return an integer array answer, where answer I is the answer to the ith array. Okay, so we start with this. So we say query I, so this number, hold on, value index, so 0, we'll add 1, and the sum is 8. And then if adding, this is -3 to 1 with -1. And I remove a 2, yes. Now we add a -4, it's -2. And the value becomes 2 because it's -4. Okay, so I think I know. So we basically just get all the even values, get all the indices as well. For even indices and odd indices, right? And then we get all the even values into a sum. Then we do this. We go look at that value, right? We'll look at that value, and then we will change it. And then note if it's an even afterwards. If it's an even afterwards and the previous is an odd, then we add the entire thing. Positive or negative. If it's previously is an even, then we add the difference, right? We add the difference. And then once we did that, yeah, that shall be it. Let's see. Okay, so we need to first get the S. Shall be sum v for v in nums if v 0. Okay. Then for v index in queries, new num equals nums index plus v. We say if new num is this is even. Now we say if nums index is odd, then s plus equal to new num, else s plus equal to new this minus nums index. Because we remove this and we add a new one. Right. And if new num is odd, then we don't do anything, and then we reset this one to new num. And then after that, when you have a res, res. Eight, 6, 4, 2, 2, 4. Ooh, what happened? So the first one, right? The second one, what's the second one? Second one is adding -3 to nums1. And nums1 is a 2. Oh yeah. A new number, previous number is a 2. So now I'd add -3. Oh, they become odd. I forgot to minus. If new number is this, aleph, nums index is this. So this is, new one is odd, but nums index is even. In this case, s minus equal to nums index. And if new num and new num and previous are both odd, we don't make anything. And we're missing anything? Should be right. Okay. $9.85. Straightforward. Solution. Follow the instructions and change and analyze each query on its own. Okay. I'm pretty sure the solution is the same. But curious. Just gonna take a look. I don't think there's any change in the test case either. I think it's the same number of test cases. 58. Yes. Okay, if this is an even, we also minus even, and then we will do this. And yeah, it does. This is the previous one. Similar idea as this one. Yeah, that's true. We always minus, update, and then plus. Better implementation. That's it. Shouldn't include this. It doesn't make any sense. Anyway, so this is good. Okay, let's try this one. Oh, this is just delete. You are given a node to be deleted. You will not be given access to the first node. What the hell? That is interesting. All the values are unique. It's not the last node. Delete a given node. Note that by deleting a node do not mean removing it from memory. We mean the value of the given node should not exist in the linked list. The number of nodes in the list should be decreased by 1. All the values before node should be the same order. All the values after should be in the same order. Should not be the last node, and it should be an actual node in the list. In the list, and it's not a tail, so it's not the last one. Of course it's not the last one, because you cannot redo if it's the last one. This is actually the big hint. We do not mean to remove it from the memory, right? So I think what it wants to do is just move everything up. Move every value up, and then when you get the last one, you just delete the last one. I think that's what it means. Let's give it a shot. Otherwise, I don't think you can do it. Alright, I thought this was an easy problem. It's just deleting a node. But it was not. It's slightly more complicated than that. Okay, so basically what we're doing is we have a node, and then from this node we want to walk. For each one, we have a current node, and we have the next node. Actually, we shall stop at the current dot next. We shall stop here. I have a current node, I'm going to have current dot next, right? And then we say current dot val equals current dot next dot val. Then we move on to the next one, right? And then we stop, say current dot next. If current dot next is an empty, is a null, then we already cannot do anything because I need to. So current equals current dot next. But I get this value here, and I should not move to the next one. So we should say while node dot next. We know node dot next must be, because node is not the last one. So while this node dot val equals node dot next dot val, node equals node dot next, right? And then node equals node dot next. As if node dot next is empty, then we come out node dot val equals node dot next dot val, and node dot next equals none. And that is it. I don't think we'll return anything. Yep. I'm pretty sure we can do like this. Edge case was the first node, and we cannot do the last node. Yeah, I think that's the one. Yep. the hint is that we don't have to remove the node from memory. So we just update the values, right? Update values by moving the next node's value to the current node until we reach the node before the last node, and we just close the linked list there. Oh, and complexity. It's slow, but I don't see it. I don't see another way. Do we have another way for this? Delete next node instead of the current. Oh. Oh, shoot. Ha. Yep. Oh, I'm being so dumb. Delete the next node from the official solution. Just delete the next node and then update the current node's value with the next node's value. I did not think about that, and it's guaranteed we have a next node. So basic say node.val equals node.next.val, and then node.next equals node.next temp equals node.next.next, and then node.next equals temp. Temp.next equals none. Close that one. How did I not thought about this? I don't know. Seems very obvious to me. None type. Oh, of course. And then I just don't do this. Then I even need this one. Maybe I can do something like this. Yep. Surely can. I don't know. So stupid. So dumb of me. This is a 1. Of course. I see what you're doing. Yeah, this is not, I mean, you're not supposed to be, you're not supposed to do this. Because something might be pointing to this one. So ideally you should be deleting this one, but you can't, because you cannot reference the ones before. So that's why it's more of a twister, right? It's a mind twister. Yeah, I agree with this one. Yeah, that's a good point. Alright, that'll be it for today. Fast. Alright, see you guys tomorrow. Adios.